So let's take a look at our loan formula, but this time we're going to be solving for one of the variables, time. And how can we go about doing that? Well, we're going to have to use the concept of logs. So if you haven't reviewed the idea of logs or you're not sure what a logarithm is, I suggest looking at my review of logarithm concepts that I also posted. But in this case, we see that we have this formula, and they gave us several of these values in here, and you're going to see there's only going to be one variable that's missing that we need to solve for. So what do we have here? We're going to borrow $280,000. So remember, this is our principal. That's what P is. So let's write that down. That is going to charge us a 4.3% interest rate, so that's our R. And don't forget that 4.3% written as a decimal is 0.043. And also it's compounded monthly. So when it tells us our compounded monthly, that's what the T is, because the T is the number of times that this is going to happen in a year, since we're usually talking about annual interest rate being every year. So monthly is going to be 12. It happens 12 times a year. And it says that you want to make payments in the amount of $1,400. So D is our desired payment, how much we're going to pay every single time. And since it's monthly, we're going to do this every month. And so we notice it's asking for how many payments will it take to pay off the loan. So the number of payments is actually not one of the variables here, but what we're going to need is to figure out the number of payments is how many years, right here. How many years, the N in this case. That's what is missing here. If we know how many years we have, then we can just multiply it by 12, and then we'll know how many payments, because there's 12 payments in a year. So let's plug in all this information here, and we'll go through the process of solving, simplifying, and solving for N, right? That missing piece that we need to answer the question. So filling this in, I have P is 280,000 is equal to D, which is 1,400, times 1 minus 1 plus R over T. So I have 0.043 over T, which is 12. And then raised to the negative 12 for T again, N. And that's our variable that we're trying to figure out. And now we have this whole thing over R over T. So 0.043 divided by 12. So the first thing we want to do in solving this equation is we notice that we have this complicated fractions within fractions. It's taking this top divided by the bottom. So let's get rid of this piece first, right? We're dividing by this fraction. So how do we undo division? We're just going to use multiplication. So on both sides, we're going to multiply by 0.043 over 12. And we're going to do this on the other side as well. Now, one thing you can do is, if you want, you can already take your calculator and start multiplying that out. But you're going to see that a lot of times what we prefer to do is just writing it out and then doing just the calculation at the very end. So that way we don't have to worry about rounding any numbers off that then make our answer slightly wrong. So I will just write this out as 280,000 times the 0.043 over 12. And on the right side, basically since we multiplied, we did that to cancel this out. The multiplication will cancel out the division. And so we're left with 1,400 times 1 minus 1 plus 0.043 over 12 raised to the negative 12n. So next, we can't touch anything in here yet because this 1,400 is still on this outside being multiplied. So there's two ways you can handle this. One is you can either distribute, or two, we can just divide it out. And I find it easier to just, let's divide it out already. Right? So if this is multiplication here, I'm going to divide by the 1,400. And how do we divide by 1,400 here? You can either put the whole thing on the bottom. Multiplication, division all happen at the same time, so I'm just going to actually put the 1,400 over here. Right, so let's see where we're at now. We have the 280,000 over the 1400, and we're still multiplying by the 0.043 over 12. But on the left side now, what do we have is these cancel out, and I'm just left with the 1 minus 1 plus 0.043 over 12 raised to the negative 12n. So what is our next step? I still can't get to this exponent, right, which is on this parentheses of the 1 plus 0.043 over 12. But what we can do is this 1 now, since that 1400 is gone, we can get rid of that, right? We have a positive 1 here, and we need to get rid of it, so I'm going to subtract 1 on both sides. So if I subtract 1, I'm going to end up with So you'll notice here that we still have this minus sign that was left behind, right? So don't forget that, right? When we subtracted the 1, it got rid of this 1 in front, but that we're still subtracting this, so it still has to be negative here. Well, before we can still again get to that exponent, the last thing we have to worry about is how do we get rid of that negative? Well, it's a negative 1. Right? That we are multiplying by in front, basically. So we can just divide everything by negative 1. Or you can think of just multiplying by a negative. Another way you can think about it is if I divide, it's just going to switch this to a positive. And when we do it on the other side, anything that's positive is going to become positive. Anything that's negative is going to become negative. So I'll just do that. So if we divide by negative 1, this term right here is going to become negative. And this minus 1 is going to become positive. And now this becomes positive. So now we're almost done here. Because what do we need is now that we have the parentheses with our variable on top, now we can get rid of basically this base and bring that down. Because from what we just learned in the last video is that how do we get that exponent down is we can take the logarithm. So we're going to take the log of both the left side and the right side. And so I'm going to need some room here to write that. So remember, we're going to take the log of the left side. So I'll fill that in. And then we're going to take the log of the right side. So we'll fill that in. So filling this in gives me this whole thing inside here. And then here, I'll fill this whole thing in here. Right, so we're taking the log, meaning we're asking what's the exponent on 10 that gives us this. And as we saw in our property of logs, now because we are taking the log and there's already an exponent here, we can move that down to the front and now solve for n. So in this almost last step, we have still the log of this whole thing. And now, because this is all multiplication, we can just divide by everything to get n by itself. So our last step would be to divide, and then we can just type it into our calculator at the end. So if I divide, what am I dividing by? Well, we need to divide by the negative 12 to cancel that out. And we also need to divide by this log of the 1 plus 0.043 over 12. And what we do on one side, we'll do to the other. And to find n then, because all of this cancels out, we just type this whole expression into our calculator. So let's take the time to do that. Right, so I'll build the fraction first. Then on top I have log of negative 280,000 over 1,400 times 0.043 over 12 plus 1. And then on the bottom I have negative 12 times log of 1 plus 0.043 over 12. And what does this give us is 29.38. And this is the number of years. So now, to answer the question of how many payments is this, well, we know there's 12 payments in a year, so let's just take the 29.38 and multiply it by 12 to figure out the number of payments. And when we do that, I get 352.57 payments.